is to solve for x when you see what's called a rational exponent in the problem. Rational exponents, remember when I say the word rational, that's actually just fancy talk for fraction. So how do you get rid of an exponent that's a fraction is what we're going to take care of today. So the strategy is actually up there on the board. When we solve an equation involving rational exponents, we actually just solve those equations by using SADMAP, or by solving by undoing. Now, speaking of solving by undoing, I have to do a little throwback to Algebra 1, if you will. I'm going to write something on the smartboard. You do not need to write it down. Doesn't happen often, but it's going to happen right now. I have a question for you. Let's say I make up a problem, you know. Let's say I say 3/4 x equals 9. 3/4 of some number x yields 9. I have a question. My question is, how in your math history, in your experience, how have you solved that for x? There's a couple of different ways that I think you did it, John. So you did it like this. You would multiply both sides by 4 first. So you'd have 3x then equals 36, is that right? And then you divide everything by 3, and you get 12. Is that the consensus in the room then? Like everybody did it that way? Okay. I'm going to bring another way of doing this same problem to your attention. You may have seen it. If you have seen it, you could let me know. That'd be great. So let's do this same problem again. Okay. There's actually a way you could get rid of that 3/4 just with one step instead of 2. I don't know if you know this or not. Do you know it, Alex? Yeah, you multiply by the reciprocal on both sides. So check it out. If you multiply both sides by 4/3, here's the magic that happens. So what you could do in 2 steps, you could actually do in 1. If you just multiply both sides by 4/3, you know that when we multiply fractions, you just go straight across. So on the left side, what we actually have right now is 12 over 12x. 12 out of 12, that's just 1. So the x got isolated just by multiplying both sides by the reciprocal. And then just to simplify across the top on the other side, you know, we have 36 over 3, which you just said was 12. So there's this idea that, and it's actually the more important idea for today, there's this idea that we could get rid of a fractional coefficient by multiplying by the reciprocal. Did you know that? Okay, so let's do another one just to make sure that that idea sticks. So, hey Eddie, pick a fraction for me. Woo. Okay, and then Nikki, pick a number for me. 16. Yeah, that's what I'm getting at. Good girl. So in this case, I have a question for you. How would I get rid of 7/12 if we use that second case that Brooke is just talking about? What would you multiply both sides by, Tammy? Very good, 12/7. Now, Eddie went ahead and picked kind of a messy number. But the idea here is that we could get rid of 7/12 by multiplying both sides by 12/7. And then we would just multiply straight across. So you get 16 times 12 over 7 times 1 to kind of help you out. Yeah, 92 over 7, something like that. 192. So are you okay with that? Today we're going to work on getting rid of our fractions by multiplying by the reciprocal. That's what's going to happen. All right, cool. So let's get started. We really only have 4 problems, and they're pretty short. If you understand multiplying by the reciprocal to get rid of a fraction, then you're pretty well off. Like I said, the technique we're going to use today is a technique that you're all very familiar with. It's called solving by undoing. Basically, we peel off the layers around x until we get that x by itself. I call that process SADMAP. You could call it solving by undoing, whatever you like to do. So yeah, we need to get x by itself. That's what it means to solve for x. So I'm going to go ahead and start by writing out the letters that indicate the steps I should go through. So step 1 is to look for any subtraction or addition that I see in the problem. But I don't see any. I hope you don't either. Get your eyes checked. No subtraction or addition appeared in this problem. The next thing we would do is look for any division or multiplication that you see in the problem. So here I see 9 times x to the 3/5. I can get rid of that multiplication by dividing. So I can divide both sides by 9. So now I have x to the 3/5 equals 72 divided by 9. The quotient 72 over 9 evaluates to 8. Now I have to take care of my exponent. You see how it's raised to the 3/5 power? We can actually multiply 3/5 by something and make it go away. Anybody care to guess what that is? 5/3. Very good. So we're going to raise this side to the 5/3 power. But what you do to one side of an equal sign, to the other, yeah. You people know me. So you got x all by itself, right? That's nice. Problem here is we now have 8 to the 5/3 that we need to simplify a little bit. So you might remember from a little bit earlier on in the chapter that we have this thing called the ER rule, which says that taking 8 and raising it to the 5/3 power is actually the same thing as taking 8 and cube rooting it, because the denominator is always your root. And then the top number 5 is your exponent. So E over R, 5/3. 5 is your exponent, 3 is your root. Cube root 8, that's easy. It's just 2, right? So we have 2 to the 5th, which evaluates to 32. So the answer for x in this particular equation is 32. 32, take the 5th root of it, that's 2, cube it, that's 8, times 9 is totally 72. So that answer even works when you plug it back into the original. All right, let's do it again. Woo. Number 2. Want to solve using StatMap? You have to undo any subtraction or addition that you see in the problem, but be careful. We can't add 4 to both sides to start off this problem. Anybody tell me why? Oh, very good. She said it very quickly, I might add. Did you follow? She said there's parentheses there. So that comes at the very end of StatMap. We can't necessarily add 4 to both sides right now because parentheses comes at the very end. So you just got to get rid of the exponent. Yeah, how do we get rid of the exponent? Multiply by the reciprocal. So we have to raise that right side to the 3/2 power. I said right, but I meant left. Okay, so you raise the left side to the 3/2 power. What you do to one side of an equal sign, you have to do to the other. So I had to raise the right side to the 3/2 power. We're learning today that if you multiply by the reciprocal, the fraction just evaluates to 1. So we get x minus 4 equals 25 to the 3/2 power. 25 to the 3/2, ugh. I can evaluate that to make that a little nicer looking. That's the same thing as taking the square root of 25 and then cubing it. So square root of 25 is 5. 5 cubed is 125. And I'm almost done. Now I'm undoing what's in the parentheses. Do you see how the parentheses fell off? So I can add 4 to both sides. If I add 4 to both sides, I get my x all by itself. So x is 129 in this problem. If you plug it in, it does work. 129 minus 4 is 125. Cube root it, you get 5. Square it, you get 25. So this actually does work when you plug it back into the original equation. All right, we'll do one more together, and then number 4 is all you, kiddos. So number 3, super fun. 2 fractions, 1 problem. Yay! So for number 3, you see I have 1/7 times the quantity of x plus 9, all raised to the 3/2 power, and then that equals 49. So again, going backwards through our order of operations, we have to undo any subtraction or addition that we see in the problem. You can't subtract 9 from both sides right away because that's in parentheses, so you got to wait. Next, I'm going to undo any multiplication or division I see. I see multiplication, do you? Where? Yeah, 1/7. So how do you get rid of the 1/7? Do you know, Rick? How do you get rid of that 1/7? Yeah, multiply by the reciprocal. So we're going to multiply both sides by 7. So that goes away. 1/7 of 7 is just 1. So that's gone. We now have x plus 9 raised to the 3/2 power equals 49 times 7, which is 343. Next, I need to get rid of that 3/2 that's hanging out up there. So what do I multiply that by? Gone. 2/3, and I did hear it around, so it sounds good. What you do to one side, you have to do to the other. So those go away. On the left side, we now have x plus 9. And on the right side, we have 343 raised to the 2/3 power, which is the same as cube rooting 343 and then squaring it. Cube root of 343, I think, is 7. And then 7 squared is 49. And then you're almost done. You just have to subtract 9 from both sides. 49, take away 9, is 40. So that's that problem there. Okay, now you get to try one. See how you do. Remember, you want to go backwards through the order of operations, step by step. All right, so your answer to problem number last, a lot of you are coming up with it right now, I can see. You did a nice job. So you do go backwards through the order of operations. As I walked around and took a look, you are subtracting 44 from both sides. 556 take away 44 is 512. And then from there, you have to get rid of your 3/4. So you raise both sides to the 4/3 power, which means that you end up taking the cube root of 512 and raising it to the 4th power. That's like 8 to the 4th power, which gives you 4096. Divide both sides by 16. 256 is your final answer. So it looks like you did a nice job. Were there any questions about that one? Okay, so if you're good on that one, you're good to go. You could either start on your book work for tonight. You could start on some of the practice work that we have for tomorrow. But yeah, right now it's just practice time. Hey, what's up, Alexis?